Hello everyone, let's discuss some theoretical aspects of single phase transformer. So what are the main theoretical aspects of single phase transformer? First we would like to discuss LV winding and HV winding, step-up transformer, after HV winding, first we would like to discuss what is primary winding, then secondary winding, primary winding, later secondary winding, and fifth one step up transformer, next step down transformer, finally isolation transformer. So these are the main theoretical aspects of transformer. So before the main concept, first we have to discuss this main important terminology associated with transformer. So LV winding, HV winding. So simply LV winding is nothing but low voltage winding. Like that, what is HV winding? That is high voltage winding. What is primary winding? Simply we can represent with 1, like this we have to represent winding. Secondary winding 2 power 0, like that we have to represent, right? So LV means what? Low voltage winding. HV means high voltage winding. Primary 1 power 0, secondary 2 power 0, like that we have to represent. So first we would like to discuss what is LV and HV windings. LV and HV windings. So what is low voltage winding? What is high voltage winding? Simply the windings with less number of turns. Windings with less number of turns is called LV winding. Like that, windings with more number of turns is called HV winding. So the winding which is having less number of turns is called LV winding. Like that, the winding which is having more number of turns is called HV winding. So what is the key point here? Number of turns proportional to voltage, right? Number of turns proportional to voltage. We will derive an equation associated with this number of turns and voltage in future classes. But here the number of turns which are directly proportional to the voltage, whether it is LV or HV. So now I would like to represent where is LV and where is HV winding that we are going to obtain in transformer. Let us assume this is core of transformer. This is core of transformer, this is one limb and this is another limb. So between these two limbs we have to provide the windings. So first this is one winding, this is another winding, right? Then you have to say which is LV winding, which is HV winding. So in this limb 1, 2, 3, 4, 5, 6 number of turns are present, but in this case 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So obviously this is LV winding and this is HV winding, because the number of turns which is present in this limb are less compared to this limb. So obviously this is LV winding, this is HV winding. Now we have to write this is LV winding, like that. This is what HV winding. So like that we can differentiate LV winding and HV winding. So let us consider another core. Now we have to tell which one is LV winding and which one is HV winding. Obviously by inspection we have to tell this limb is having more number of turns compared to another limb. So this limb is having more number of turns, therefore this winding is called HV winding. Like that this winding is called LV winding. This is HV winding, like that this is LV winding. So the winding which is proportional to number of turns is called LV or HV. If the number of turns are more, that is high voltage winding. If number of turns are less, that is low voltage winding. This is about LV and HV winding. Then coming to what is primary winding, what is secondary winding. Primary and secondary winding. So let us having the core again. So for this core we have number of turns. So obviously this is LV, this is HV, right? But how we can say this is primary or secondary, or this is primary or secondary? So whenever there is a source, that is called primary winding. Whenever we have a load, that is secondary winding. So let us say this is source. We have provided a source across any winding, whether it is LV or HV. When we have a supply voltage across any winding, that winding is called primary winding. Like that, when we have a load across any two terminals, that winding is called secondary winding. So we have a supply voltage across these two terminals, therefore this winding is called primary winding. This is what? Secondary winding. We all know that this is what? High voltage winding, this is low voltage winding, right? So whenever we have supply voltage, primary winding. Whenever we have load across two terminals, that is called secondary winding. Let us so this is the core again. Again we have a supply voltage. For this we have a load. This is what? Primary winding. This is what? Secondary winding. But we all know that this is low voltage winding, this is high voltage winding. So finally what is the conclusion? Low voltage or high voltage winding plus supply, which is equals to what? Primary winding, right? Like that, low voltage or high voltage winding with load across two terminals is nothing but secondary winding. This is very important note point. Whenever we have a supply voltage between two terminals, then only we can call it as primary winding. Without any supply voltage, that winding is called as LV or HV winding only. But when we have supply as well as load between two terminals, that winding is called secondary as well as primary winding. So let us consider like that. Now I have to provide supply voltage here. There is a load, there is a supply. Let us say V1. Now I am going to connect a load between these two terminals. Supply voltage right. So this is V1. So for us, which one is primary? For us this is primary, for us this is secondary. This is what? High voltage primary winding, low voltage secondary winding. This is low voltage, this is high voltage. For us this is what? We have supply voltage between these two terminals. Obviously this is what? Primary winding. We have load across these two terminals. This is what? Secondary winding. Now we have clear idea about what is primary, what is secondary, what is LV, what is HV. Okay, whether it is LV or HV, we have supply voltage. Obviously that winding is called primary. Without supply voltage, that winding is called LV or HV only. Without load, that winding is called LV or HV only. But the combination of supply and load should be represented with primary as well as secondary windings. This is about primary and secondary windings. Now what is step-up transformer? What is step-down transformer? First I would like to discuss step-up transformer. Step up means what? We have to increase the voltage, we have to increase the number of turns across secondary. Step up, right? This is primary. We have supply voltage V1. Because of the supply we have current, therefore an EMF will be induced. Therefore an EMF will be induced. This is E1 across primary. Like that, this is E2. Obviously we have a current because there is a load across secondary. Obviously there is a current. This is what? V2. So this is supply voltage V1. So step up means what? The number of turns in primary winding should be less than primary winding, secondary winding. So simply this is LV, this is HV, that is primary winding, you can say secondary winding. So the number of turns across secondary winding should be more than number of turns across primary winding. Step up, that is the voltage across secondary winding should be more than voltage across primary winding, right? Because the winding or voltage is proportional to number of turns, that is V2, or we can say V2 should be more than V1. What is step up transformer? The secondary voltage should be more than primary voltage. Secondary voltage should be more than primary voltage. That is called step up transformer. That is the number of turns which are present across secondary should be more than the number of turns which are present on primary winding. Like that, voltage which is available across secondary should be more than the voltage which is available across primary winding. So if V2 more than V1, that is step up transformer. So what is step down transformer? Then why we need this step up transformer? To increase the voltage. Why we need this step up transformer? To increase the voltage across secondary winding. How we can increase the voltage across secondary winding? By increasing the number of turns. To increase the voltage across secondary winding by increasing number of turns in secondary winding. Simple. So in order to increase the voltage across secondary winding, we have to increase this number of turns. That's it. That is step up transformer. Then what is step down transformer? That is step down transformer. That is the available voltage across secondary should be less than primary winding. To decrease the voltage across secondary winding by providing less turns in secondary winding. So obviously the secondary winding is having less number of turns compared to primary winding. That is called step down transformer. We have supply voltage. Obviously this is primary winding. Right? So this is V1, I1, we have E1, we have E2, this is what I2, this is V2. Clear? So here V1, step down means what? Step up means what? Yeah, V1 more than V2, that is primary voltage should be more than secondary voltage, that is number of turns present in primary winding should be more than number of turns which are available in secondary winding. Right? Voltage across primary winding should be more than voltage across secondary winding. Simple. You can tell that how we can step up or step down the voltage. So in order to step up the voltage, we have to increase the number of turns across the secondary. That is V1 is less compared to secondary voltage. What is step down transformer? Primary voltage is more than secondary voltage. That is step down transformer. That is primary voltage is more than secondary voltage. Means the number of turns which are available across primary should be more than the number of turns which are available in secondary winding. That is about step up transformer and step down transformer. Now isolation transformer. What is isolation transformer? We have to use this to be used in electronic components. That is, for protection purpose we can use. So we can use isolation transformer for protection purpose. Then what is isolation transformer? That is, so by looking at the diagram you can say whether it is step up transformer, step down transformer or isolation transformer. Now we have to tell this is step up transformer or step down transformer. This is supply voltage, this is current, this is EMF, this is secondary EMF, there is a current, there is a voltage. Here the number of turns, across primary winding should be equals to number of turns across secondary winding, right? That is, V1 should be equals to V2. V1 should be equals to V2. That is called isolation transformer. This type of transformer should be used in electronic components for protection purpose. So the number of turns which are available in primary winding should be equals to number of turns which are available in secondary winding, because the number of turns which are equal, obviously the supply voltage should be equal to secondary voltage, right? So simply what is summary? LV or HV winding, like that, LV or HV winding with plus supply, which is nothing but primary winding, like that, LV or HV winding with load. If there is a load, that is called as secondary winding. And V1 more than V2, like that, V1 less than V2, like that, V1 which is equals to V2. If V1 is more than V2, that is what? Step down transformer. If V1 less than V2, that is step up transformer. If V1 which is equals to V2, that is isolation transformer. So what is coming to step down transformer? The number of turns which are available in primary should be more. Step up means what? N1 less than N2. If V2 is more, N2 is more. Coming to isolation transformer, N1 is equals to N2, right? This is about the summary of this session, that is LV winding, HV winding, primary winding, secondary winding, step up transformer, step down transformer, and finally isolation transformer. Thank you.